Hello viewers, Electric Circuits question 3. For this circuit, find the total resistance and the current through the battery and each resistor. Therefore find the power output of the battery and the power consumed by each resistor. So this circuit that we have here has a 24 volt battery and two 10 ohm resistors, and they are in parallel because any electron is either going to go through that top loop or it's going to go through the large loop. Either way, it's only going to go through one of the 10 ohm resistors. So this is a purely parallel circuit, and therefore total resistance, RT, is given by 10 to the power of minus 1 plus 10 to the minus 1 whole thing to the power of minus 1, and that gives us 5 ohms. Or we could work this out as 1 over RT equals 1 over 10 plus 1 over 10. 1 over 10 plus 1 over 10 is 2 over 10, which is 1 over 5. So 1 over RT is 1 over 5, and that gives us the total resistance is 5 ohms. Okay, so we can replace these two 10 ohm resistors with a single 5 ohm resistor, which is in series with the 24 volt battery. So let's find the current through the common part of the circuit, and by common we mean the part of the circuit where both loops, the top loop and the whole loop, have in common, which will be from here all the way round to there. Okay, okay, so we have to find that current. I is V over R, and the voltage is 24, dividing by the total resistance we found to be 5, and that gives us 4.8 amps. So we've got the current through the battery and each 10 ohm resistor. So the current through each resistor is going to be I equals V, which is 24, over 10, which is 2.4 amps. So through the common part of the circuit, we have 4.8 amps, which splits up here. So we've got 2.4 going along this way and 2.4 round the bottom part of the circuit. And then it all joins up at that part of the circuit again. So we've got our current through each resistor. Find the power output of the battery. So power of the battery is going to be I times V. Now the I is the current, which is we're looking at through the battery, so we're dealing with the common part of the current, which is 4.8, and we're multiplying that by 24. And if we calculate that, what do we end up with? We end up with 4.8 times 24 would be 115.2 watts. Okay, so we've got the power output of the battery. Now we need the power consumed by each resistor. So power of the resistor is going to be I multiplied by V, which is here the current through each resistor is, we found that to be 2.4. So that's 2.4 amps multiplied by 24. And if we calculate that, we get 57.6 watts. Okay, so we have already checked that the currents add up properly. So the current through the common part of the circuit adds up to the same as what the two parallel branches add up to. So 4.8 around here, 2.4 plus 2.4 giving you 4.8. And the power output of the battery is 115.2 watts. Each resistor uses up 57.6, So 57.6 used up by that resistor, 57.6 used up by that one. Adding those gives you 115.2, which is the output of the battery. So everything checks out as it should. Thanks for watching. Over and out.